Okay, very common problem, this intersection of two lines. A bit like with graphs, Cartesian coordinates and so on, when you've got to work out when two lines intersect. We're going to do it in vector form. Now, with this one, I'm going to start off with the IJK notation, just so you've got some familiarity with it. Okay, I prefer the column vector stuff because, well, basically with column vectors, you don't need the IJK, so it's one less thing to worry about. It just looks simpler, okay? However, this helps us to save space, all right? So you've got the equation of one line is r equals 3i plus j plus k plus lambda I minus 2j minus k. And the equation of another line is negative 2j plus 3k. Notice the absence of I component there, plus mu, negative 5i plus j plus 4k. Now I'm just going to rewrite the lines, okay, like this. So in column vector form, the first one will be 3, 1, 1, plus lambda, 1, negative 2, negative 1. Isn't that just so much easier to write that? I mean, to me, the only letters you got are R and lambda, as opposed to the IJK. All right? So that's a little bit easier from that point of view. And then the second line is, so 0, don't forget the 0, it's 0i, negative 2, 3, plus mu, negative 5, 1, 4. So that's writing them out in terms of column vector form. Okay, we're going to show that they intersect each other. Okay, well, when you've got two lines in Cartesian form, for example, like this, y equals 4 plus 2x and y equals negative a half x plus 7. You know, when you've got these two lines intersect each other, what do? Okay, you just say that y equals that, therefore this equals this. You do 4 plus 2x equals negative half x plus. That's what you do, isn't it? You do exactly the same with this. You just set that equal to that. Okay, so we're going to have that is going to be equal to 0, negative 2, 3, plus mu, negative 5, 1, 4. Let me just rub all of this off. Okay, so exactly the same thing. Okay, now, the vast majority of vector lines are all written in the form r equals a plus lambda b, which actually makes it a bit easier than Cartesian form, because sometimes you don't have a y as the subject, do you? Sometimes you've got 3x plus 4y equals 7 or something like that, and you've got to rearrange it or something. With these, you've always got r equals something, so it's just like set that equal to that. So it's much easier from that point of view. Okay, now I'm just going to rewrite it slightly. Okay, I'm going to rewrite it slightly. So first of all, I don't really like having it r equals, but I've left it there for a reason. I could also write the equations line like this: 3 plus lambda, 1 minus 2 lambda, 1 minus lambda. Can you see that? All I've done is I've just combined these and put them into one bracket. Okay. Now, you've got a top line, a middle line, and a bottom line, haven't you? They stand for an I, J and K component. Effectively, your top line represents your X coordinate. Your middle line, the Y coordinate, the bottom line, the Z coordinate. Okay? And so sometimes writing like that is a bit simpler. That's your X coordinate, Y coordinate, Z coordinate. Okay? Let's see what it's like for this one here. Okay, so that would be 0 minus 5 mu, negative 2 plus mu, and then 3 plus 4 mu. So I'm just checking that I've written everything down properly. Okay, so your X coordinate, Y coordinate, Z coordinate, X, Y, Z. Now we rub that off now. Okay, you see that? Now, because that X coordinate must be equal to that X coordinate, we can just write down that equals that. That Y coordinate must be equal to that Y coordinate, because that's how straight lines work. You know, again, see the link with mechanics. When you've got two lines that intersect each other, so mechanics, it's normally you've got expressions for position vectors, okay? When there's a collision, for example, they occupy the same point, they map same X, Y and Z coordinates, okay? So you can put the X, Y, Z coordinates all together, okay? So what that means is, I can write it a little bit neater like this. You can say that 3 plus lambda equals negative 5 mu, yeah? 1 minus 2 lambda is equal to negative 2 plus mu, and 1 minus lambda is equal to 3 plus 4 mu. I've rubbed it off because I don't need it. Okay, so you can see what's happened there? Yeah. So that's just setting the x coordinates, y coordinates, and z coordinates equal to each other. Okay, now I'm just going to write it above here. Okay, just so that my solution looks just a little bit better. So what have we got? We've got simultaneous equations. Do not panic, because there's 3 of them. You've got 2 unknowns. You only need 2 equations to solve 2 unknowns, don't you? So it's your choice. You choose which 2 equations to use. Okay, I'm going to use that one and that one there. Okay, I'm going to number them 1, 2 and 3, but I just won't put in the... Okay, I'll put it in. But I'm going to do equation 1 and 3. Because I notice we've got lambda, negative lambda. I can very easily just add the 2 together, can't I, to eliminate the lambdas. So 3 plus 1 is 4. They cancel. And then you've got 3, and then 4 mu minus 5 mu, so that's subtract mu. Look how easy that is. Okay, put the mu onto that side. Okay, so you get mu equals negative 1. Okay. From that, I can work out what lambda is. So I'll use equation 1 to do that. So mu is negative 1, so that's got to be 5. Lambda equals 2. Now you should always check that it works in all 3 equations. Okay. Remember the question was, show that they intersect. So just check they work with all 3 equations. Okay. If you want, you can do that mentally for the moment. Okay, so let's just do that. So you've got 3 minus 1 is 2, and no, I messed it up already. 3 plus 2 is 5. Negative 5 times negative 1 is 5, so yeah, that works. And then 1 subtract 4 is negative 3. Negative 2 plus negative 1 is also negative 3, so that works. 1 minus 2 is negative 1, and 3 subtract 4 is also negative 1. Okay, so that works. That shows that lines intersect. If they did not intersect, then you would not be able to find values of lambda mu that work in all 3 equations. Okay, you might be able to find a value of lambda mu that works, say, in both those equations, but not in that one. When that happens, that's a proof that they don't intersect. Okay, it's a bit like a proof by contradiction, that one. You assume they intersect, so you start off by doing all this, and then you note the contradiction because you can't fit lambda mu in all 3 equations. Okay. Now, for the point of intersection, okay, that is sometimes abbreviated to POI, okay, point of intersection. Right? You just choose either of these equations to put them in. Okay, so let's just, I'm going to write it down as a coordinate. Okay, let's just choose this one there. Okay, so lambda is 2. Okay, so you get 3 plus 2, which is 5. And then you get 1 subtract 4, which is negative 3. And then you get 1 subtract 2, which is negative 1. Now I'm going to check that it works in that one as well, using mu is negative 1. So 0 plus 5, good. And then negative 2 plus negative 1, good. And then 3 subtract 4, good. Okay, so that's our point of intersection. Okay. So that's done 2 things for us. It's shown the lines intersect, and it's found the point of intersection for us. Okay. Go back to that example, not literally, just think back, to that example where we looked at the cube and we showed that the diagonals intersect each other. You can apply this same technique with various other shapes. Okay, as long as you can find an equation of a line, okay, of the diagonals you need, you can show they intersect by doing the same thing. Okay. All you need, as I showed you in the last example, all you need is 2 points, 2 coordinate points, and you can find an equation of a straight line between them. Okay, so if you can find the equation of 2 different straight lines, okay, you can show whether they intersect or not. You can find the point of intersection. That is just really helpful. Okay, really helpful. Okay, because that means you can think of any shape you want, 2-dimensional or 3-dimensional. Okay. If you know the coordinates of the vertices of those shapes, they can be as easy or as hard as you want. Then you can work out the equation of a straight line between 2 points, and then you can use this technique to show whether they intersect. Okay? And believe me, the vectors method here is the simplest mathematical method to do that. because you don't want to be hanging around with trigonometry. Okay, it's just be far too complicated. Okay, that would be the other method, incidentally. And you don't want to try and find Cartesian equations because that is going to be a bit tricky as well. Vectors is the simplest method of doing it.